What does a world look like when no one can truly see inside it? Not the surface, not the clouds, not the polished images sent back by spacecraft, but the deeper place beneath all appearances, the hidden engine where heat gathers, metals move, and the history of a planet is written in silence. We tend to imagine planets as finished objects, a blue sphere, a red desert, a ringed giant hanging in darkness. From far away, they seem complete, almost simple, as if distance itself has smoothed away their contradictions. But every world is divided between what it shows and what it keeps. Beneath crust, storm, and ice, there are buried structures we have never touched, chambers we know only through vibration, gravity, magnetism, and inference. We do not open planets, we listen to them. That is what makes this journey so strangely intimate. To study the interior of a planet is to study a hidden life, a molten heart that still turns, a magnetic field that rises and vanishes, layers of matter pressed into forms that do not belong to ordinary human experience, liquid metal, superheated stone, ice that behaves like fire, hydrogen transformed into something so exotic it barely fits the language we use for matter at all. And yet the mystery is not only scientific, it is human. Because every attempt to understand a planet's interior reveals the same quiet truth. The most important things are often the least visible. The force that protects an atmosphere may lie thousands of miles below the surface. The cause of a silent death may begin in a core no eye will ever witness. So this is not simply a story about planets. It is a story about hidden structure, about unseen causes, about the distance between what we observe and what we understand. And as we descend through rock, storm, metal, and time, we may discover that the deeper we look into other worlds, the more clearly we recognize our own longing to know what lies beneath the surface of everything. What happens when a planet's heart keeps beating, but its voice is gone? The question hangs over Mars like red dust at dusk. In November of 2018, NASA's InSight lander settled onto a plane called Elysium Planitia and did something beautifully simple. It listened, not for wind, not for weather, but for the faint tremors moving through the ground beneath it. Over the years that followed, Mars offered more than 1,000 quakes, small, distant shudders from a world that looked quiet from orbit and ancient from the surface. What those signals revealed was unsettling. Mars is not a solid, frozen stone all the way through. Deep below its rust-colored deserts lies a liquid core, rich in iron and mixed with lighter elements like sulfur. In another context, that might sound promising. On Earth, a restless metallic core helps generate the magnetic field that shields oceans, air, and life itself. Mars once had such a field too. Ancient rocks still carry the memory of it, like a faded recording etched into stone. But somewhere in the long passage of planetary time, that protection failed. The dynamo weakened, the shield vanished, and with it, much of the atmosphere slowly slipped away under the pressure of solar wind. Rivers dried, the climate changed. A world that may once have held lakes and weather became thin, cold, and exposed. That is what makes Mars feel less like a distant object and more like a warning written in geology. A planet does not always die in fire. Sometimes it fades from the inside outward, losing the invisible systems that made the visible ones possible. And so Mars leaves us with a thought, both scientific and deeply human. How often do we notice a world is changing only after the protection is already gone? What if the planet we know best is still, in its deepest places, a matter of faith? Earth feels familiar because we stand on it, map it, build on it, name every visible corner. But the farther down we imagine going, the less certainty we possess. No human being has ever reached the mantle. The deepest hole ever drilled barely scratched the skin of the world. And so our understanding of Earth's interior begins not with sight, but with echoes. When earthquakes tear through rock, they send waves racing through the planet in different ways. Some pass through solids, others slow, bend, or vanish in liquid. From those changes, scientists assembled a portrait of the unseen. A thin crust, a vast mantle of slowly moving rock, a liquid outer core, and inside that, a solid inner core under extraordinary pressure. It is a strange idea, almost poetic in its contradiction. At the center of a blazing hot planet sits a sphere of iron so compressed it cannot melt. Around it, liquid metal churns in darkness, generating the magnetic field that shields Earth from charged particles streaming from the sun. The compass in a hiker's hand, the aurora over polar skies, even part of the reason our atmosphere has endured. All of it is connected to motions unfolding far below any horizon we will ever cross. Yet Earth's interior is not merely a hidden machine. It is also a source of instability. Continents drift because the mantle moves. Mountains rise because plates collide. Volcanoes, earthquakes, oceans, and atmosphere all belong to a single restless system powered partly by heat from the deep past. The ground beneath us feels still only because our lives are brief. Perhaps that is Earth's quiet lesson. Stability is often movement seen at the wrong scale. What feels permanent may simply be change unfolding with a patience larger than our own. What if a world could be nearly the same size as Earth and still become its opposite in every way that matters? Venus drifts through our imagination as a twin, gone elsewhere, a planet with familiar dimensions and utterly unfamiliar fate. From a distance, it glows softly, wrapped in bright cloud. For centuries, that brightness invited projection. Perhaps jungles, perhaps oceans, perhaps some warmer version of home. But the clouds of Venus do not hide life-friendly weather. They conceal an atmosphere so dense and carbon-rich that the planet's surface is crushed beneath immense pressure and heated to temperatures hot enough to melt lead. It is less a landscape than a sealed chamber, and still the deepest mystery lies below those clouds and below the scorched plains. Venus appears to have a metallic core, probably like Earth's in broad composition, but the planet has no strong global magnetic field today. That absence matters. It suggests a different internal rhythm, a different conversation between heat, rotation, and liquid metal. Scientists still debate the exact reasons. Perhaps the core cools differently. Perhaps the planet's slow spin changes the dynamics. Perhaps the story is written in a past we have only begun to reconstruct. The surface itself seems to remember catastrophe. Vast lava plains stretch across the planet, and some researchers suspect Venus may have undergone episodes of large-scale resurfacing, as if the world periodically remade its own face in fire. Not the steady plate tectonics of Earth, but a more episodic release, heat building in secret until the crust could no longer contain it. That possibility gives Venus its haunting power. It is not simply hot. It is a reminder that worlds can drift into imbalance and then normalize that imbalance until it becomes their identity. A planet can keep all the appearance of kinship while losing the conditions that once made kinship meaningful. Venus asks a difficult question, one that reaches beyond astronomy. How much can remain outwardly familiar even after the inner balance has been lost? What if the smallest planet carried one of the largest secrets? Mercury, scorched by the sun and stripped down to essentials, looks at first like a relic, an old, battered sphere of rock and craters. But beneath that austere surface lies one of the strangest interiors in the solar system. Mercury is small, yet its metallic core is enormous, taking up a far greater share of the planet than Earth's core does of ours. It is as if much of the world is hard, with only a comparatively thin shell of rock around it. That alone would be remarkable. More surprising still, evidence suggests part of that core remains molten even now. For a planet so small, one might expect the interior to have cooled and stiffened long ago. Instead, Mercury still holds on to heat, and with it, a weak but real magnetic field. That field is not as strong or protective as Earth's, but its presence changes the way we see the planet. Mercury is not merely a fossil from the dawn of the solar system. It is active in subtler ways, still carrying an internal memory of formation and transformation. Some scientists think its oversized core may be the result of violent early collisions that stripped away much of its outer rock. Others see in it the imprint of how material condensed near the young sun. Either way, Mercury seems shaped by extremes. Its surface tells another quiet story. Long cliffs stretching for hundreds of miles suggest that the planet has shrunk as it cooled, wrinkling like fruit left in dry air. The crust remembers contraction. The core remembers motion. Between them lies a record of a world becoming smaller, denser, and more inward over immense time. Mercury feels almost monastic in its severity, yet that severity is what makes it beautiful. It reminds us that simplicity on the surface can conceal profound complexity below. Sometimes the most stripped-down worlds are the ones that force us to ask the deepest questions about how much can be lost and how much can still remain alive within. What if the largest planet in the solar system has no true surface at all, only a long descent into pressure, darkness, and transformation? Jupiter does not invite landing, it invites surrender to scale. From afar, it is all motion, bands of cloud, white storms, rust-colored belts, the great red spot turning like an old wound that never quite closes. But those visible clouds are only the thinnest outer gesture of a much deeper world. Drop beneath them, and the familiar idea of landscape disappears. Gas thickens, pressure mounts. The atmosphere becomes oceanic in feeling, then stranger still, until hydrogen, the simplest element in the universe, begins to behave in extraordinary ways. Deep inside Jupiter, scientists believe hydrogen is compressed into a metallic state, not metal in the everyday sense of something forged or held, but a fluid capable of conducting electricity. It is this immense hidden layer, moving under colossal pressure, that likely helps generate Jupiter's powerful magnetic field, one so vast it creates an invisible kingdom around the planet, trapping radiation and shaping space itself far beyond the cloud tops. And below even that, perhaps, lies a diluted or partially dissolved core, less a neat central sphere than a blurred memory of one. Recent research suggests Jupiter's interior may not be cleanly layered like a textbook diagram. It may be more mixed, more turbulent, more ambiguous. In a world this large, categories begin to soften. That uncertainty matters. Jupiter is not just a giant version of a planet we know. It is a different kind of reality, where pressure rewrites matter and size becomes destiny. Its inner structure may preserve clues to the earliest moments of the solar system, when planets were not yet settled identities, but experiments in accumulation, gravity, and heat. Jupiter leaves us with an unsettling thought. Perhaps the deeper we go into the largest things, the less they resemble our expectations. There may be no solid ground waiting at the end of understanding, only deeper layers of wonder, where even simplicity becomes strange. What if beauty itself could hide a violence? Saturn is often introduced as the graceful one, the planet of rings, the distant emblem of balance and elegance. But beneath that quiet splendor lies an interior shaped by weight, pressure, and a slow rain of elements through darkness. The rings draw our eyes first, and perhaps that is part of Saturn's mystery. They make the planet seem almost delicate, as if it were defined by lightness. Yet Saturn is a giant, made mostly of hydrogen and helium, with an interior that grows increasingly severe as one moves downward. Like Jupiter, it has no simple surface where sky ends and ground begins. There is only descent, clouds becoming denser layers, gas turning fluid-like under compression, and deep within, hydrogen entering exotic states that challenge ordinary intuition. Scientists think Saturn may also contain a core of heavier material, rock, metal, and ice from the early solar system, though the boundary between that core and the overlying layers may not be sharply defined. Some models suggest the interior is diffuse, with material mixed over great depths. And then there is one of the most haunting possibilities of all: helium rain. Under the immense pressures inside Saturn, helium may separate from hydrogen and fall inward as droplets, releasing heat as it descends. It sounds impossible, almost mythic, yet it may be part of what keeps the planet warmer than sunlight alone can explain. That image lingers, rain falling not through air, but through compressed layers of a giant world, deep below any visible storm. It reminds us that nature often writes its most astonishing poetry in the language of physics. Saturn is a lesson in contrast. The rings are temporary, fragile on cosmic timescales. The interior is ancient and immense. What looks serene from afar is restless within. And maybe that is why Saturn moves us. It reflects a truth we recognize in ourselves. Grace is not the absence of pressure. Sometimes it is simply what pressure looks like from a distance. What if a planet could be tilted so far that it seems to have fallen over and still keep turning through the dark? Uranus feels like a quiet anomaly, a world that resists the neat symmetry we often expect from the solar system. Its color is subdued, a pale blue-green softened by haze, almost gentle to the eye. Yet its strangeness begins with orientation. Uranus rotates on its side, or nearly so, as if some ancient collision long ago knocked it into a new posture and left it there. The seasons that follow are extreme beyond ordinary imagination. For decades at a time, one pole leans into sunlight while the other recedes into prolonged night. That outer calm hides an interior unlike the gas giants usually pictured beside it. Uranus is often called an ice giant, though the word ice can be misleading. Deep inside, the planet is thought to contain vast layers not of everyday frozen water, but of superheated, compressed substances such as water, ammonia, and methane in exotic fluid states. Under extreme pressure and temperature, these materials become something between liquid and plasma, a conductive dynamic medium that may help produce Uranus's odd magnetic field. And odd it is. The magnetic field is tilted sharply relative to the planet's rotation and offset from the center, as though the hidden engine generating it were displaced or asymmetrical. It does not feel like the orderly magnetism of a neatly layered world. It feels fragmented, skewed, almost improvised. Uranus seems to suggest that planetary interiors do not always organize themselves according to human preference for balance. There is another mystery, too. Uranus emits surprisingly little internal heat compared with its giant neighbors. Why it appears so thermally restrained remains uncertain. Perhaps that ancient impact altered more than its tilt. Perhaps its deep interior holds heat in ways we do not yet understand. Perhaps silence itself can be structural. Uranus reminds us that not every world announces its complexity with storms or brightness. Some of the strangest realities in the universe speak softly, and sometimes the most profound mystery is not what erupts, but what remains strangely still. What if the farthest giant is not quieter than the others, but simply harder to hear? Neptune lives at the edge of ordinary perception, a deep blue world so distant that sunlight reaches it thin and delayed, like memory arriving late. And yet this remote planet is anything but dormant. Even from billions of miles away, Neptune has revealed a kind of weather that seems almost impossible. Winds race through its atmosphere at extraordinary speeds, faster than the strongest hurricanes on Earth. Dark storms appear and fade. Bright clouds drift high above a world that receives only a fraction of the sunlight that warms Jupiter or Saturn. Somehow, Neptune remains intensely active, as though it were drawing energy from a private reservoir hidden far below the visible sky. That hidden reservoir is the key. Like Uranus, Neptune is an ice giant, thought to contain deep layers of water, ammonia, and methane in superheated, high-pressure forms unlike anything familiar in daily life. These are not simple frozen materials, but dense, reactive fluids existing under conditions that challenge the usual boundaries between liquid, gas, and electrically active matter. Beneath them may lie a core of rock and metal, compact and hot, holding the early memory of planetary formation. Its magnetic field adds another layer of strangeness. Like Uranus, Neptune's magnetism is tilted and offset, hinting that the dynamo generating it may operate not in a central metallic core like Earth's, but within those unusual conductive layers higher up in the interior. The architecture is unfamiliar, and that unfamiliarity matters. Neptune reminds us that planets do not need to resemble Earth to possess internal logic. They can organize themselves according to other rules under other pressures, in other temperatures, and still become coherent worlds. There is something deeply moving about that. So much of the universe exists beyond our immediate intuition, yet it is not chaos. It is order written in a language we are still learning to translate. Neptune, cold and distant, asks us to stay patient with the unknown. Some truths are not hidden because they are absent. They are hidden because they live far beyond the range of first impressions. What if the coldest worlds are not empty, but layered with secrets waiting beneath the ice? Long before spacecraft gave us close images of the outer solar system, the icy moons were easy to dismiss as frozen afterthoughts, small companions circling giant planets in the dark. But the deeper we looked, the more those distant moons began to feel like hidden worlds in their own right. Take Europa, where the surface appears as a shell of fractured ice, pale and luminous, lined with reddish cracks like veins across old glass. It looks still, but almost everything about it suggests motion below. Scientists believe a global ocean may lie beneath that frozen crust, kept liquid by tidal heating as Jupiter's gravity needs the moon from within. Water, rock, heat, chemistry. Suddenly a moon once imagined as inert becomes one of the most compelling places to search for the conditions of life. Then there is Ganymede, larger than Mercury, with its own magnetic field, a sign that somewhere inside, a conductive, dynamic layer still moves. Callisto seems more ancient, less internally active, yet even it may conceal a buried ocean. Farther out, Saturn's Enceladus sends plumes of water vapor and ice into space through cracks near its south pole, as if the interior is exhaling. Titan, wrapped in orange haze, may hide an underground ocean beneath a crust of water ice, even while rivers and lakes of methane shape its surface. These moons change the emotional map of the solar system. They suggest that warmth does not always come from sunlight, and that habitability may be less about distance from a star than about internal energy, pressure, and time. A frozen exterior can be misleading. Beneath it may lie circulation, chemistry, perhaps even the slow beginnings of something biological. That possibility humbles us. It reminds us how quickly surface appearances can narrow imagination. The universe may not reserve its most interesting stories for places that look inviting. Sometimes the most promising worlds are the ones that seem closed at first glance, waiting for us to learn that ice, too, can be a veil. What if the strangest materials in the solar system are not found in laboratories, but forged naturally in the deep interiors of distant worlds? The farther we travel in imagination beneath the clouds of giant planets and the crusts of icy moons, the more matter begins to behave like a form of poetry written under pressure. Inside the gas and ice giants, familiar substances stop acting familiar. Hydrogen, which on Earth is light, diffuse, and almost ghost-like, may become metallic under immense compression, conducting electricity as it moves in vast hidden currents. Water, usually the symbol of softness and life, can be transformed into superionic states, where oxygen forms a rigid lattice while hydrogen flows through it. It is still water in composition, but not in any sense a river, rain, or sea could prepare us for. Even carbon may take on extraordinary forms. In the deep interiors of Neptune and Uranus, researchers have long entertained the possibility that carbon-rich compounds could break apart under intense pressure, allowing diamond-like structures to form and sink downward through the planet's layers. The phrase diamond rain captures the imagination because it sounds like fantasy, yet it emerges from real attempts to understand how matter behaves where human senses cannot go. These are not curiosities for their own sake. They shape magnetic fields, internal heat, density, and the long evolution of worlds. A planet's atmosphere, its storms, even its chance of retaining certain conditions over billions of years, may depend on transformations far below view. The visible world is often just the final expression of hidden physics. There is something deeply beautiful in that idea. The universe does not save its creativity for the surfaces we can photograph. It continues inward, where pressure becomes author and matter learns new identities. And perhaps that is why planetary interiors feel so philosophically rich. They remind us that reality is not obligated to remain legible at human scale. To look inside a planet is to accept a larger truth. The deeper the universe becomes, the less it resembles our habits of thought, and the more astonishingly itself it appears. What if the most important discoveries are the ones made without ever arriving? Planetary science often feels like an art of respectful distance. We cannot peel back a world's crust like paper or lower instruments casually into a giant planet's core. For now, the interiors of planets remain beyond direct reach. And yet, through patience and ingenuity, humanity has learned to read what cannot be touched. We do it through motion, through gravity, through the subtle ways a planet wobbles or pulls on a spacecraft passing nearby. We do it through magnetic fields, which reveal hidden currents in places no camera can see. We do it through seismic waves when a world is kind enough to tremble. The achievement is not that we have conquered these mysteries, but that we have learned to listen carefully enough to infer them. There is something almost musical in this process. A tremor becomes structure. A change in density becomes history. A shifting field becomes evidence of a living interior. Science at its best does not shatter mystery. It gives mystery better edges. It teaches us where certainty ends, where interpretation begins, and how much can be known without pretending to know everything. That humility matters, especially in an age that often confuses information with understanding. The planets remind us that knowledge is frequently indirect. We live by inference more than we admit. We learn the inner life of worlds the way we learn the inner life of people, by observing patterns, by noticing what changes, by listening for echoes, by accepting that some depth will always remain private. And maybe that is why the study of planetary interiors feels unexpectedly intimate. It is not just about rock, gas, metal, and ice. It is about how we meet the unseen with discipline rather than fear, how we remain curious in the presence of limits, how we build meaning from signals crossing vast silence. In the end, the method becomes part of the message. Not all truth is visible, and not all distance is emptiness. Sometimes the universe reveals itself most clearly to those willing to learn how to hear what it cannot openly say. What if, after all the measurements and models, what remains is not certainty but perspective? By the time we have traveled in thought from Mercury's oversized core to the hidden oceans of icy moons, the solar system no longer feels like a collection of separate objects. It begins to look like a library of experiments, different answers to the same elemental questions of heat, gravity, pressure, time, and chance. Each world carries its own interior logic. Earth turns deep motion into protection and renewal. Mars holds the memory of a stronger past in the silence that followed its fading shield. Venus warns how similarity in size can conceal profound divergence in destiny. The giant planets show us matter reinvented under pressure, while distant moons suggest that life's prerequisites may gather in places once dismissed as too cold, too dark, too remote. And through all of this runs a quieter realization. Interiors are biographies. A planet's deep structure is not merely what it is made of, but what it has lived through. Collisions, cooling, chemical separation, tidal strain, buried oceans, collapsing atmospheres. These are chapters written below the surface. To understand a world from the inside is to understand the history it could not speak aloud. That idea changes the way we look outward. The universe becomes less decorative and more intimate. A planet is no longer just color and orbit and distance. It is a layered memory, a body shaped by forces both visible and hidden. And the differences between worlds begin to feel less like oddities and more like variations on a shared cosmic condition. Everything is formed by pressures from within and from beyond. Perhaps that is why this search matters to us so deeply. We are drawn to hidden interiors because we live by them too. Beneath every calm surface is process. Beneath every identity is history. Beneath every present moment, a long accumulation of forces still moving in the dark. So before the journey closes, one question remains suspended between science and reflection. If every world is shaped most profoundly by what cannot be seen, how much of existence have we yet to learn simply by looking deeper? In the end, the story of planetary interiors is not really about descent. It is about relationship, between surface and depth, between appearance and cause, between the smallness of human experience and the vast, patient architectures that shape worlds over billions of years. We began with a simple question: what lies inside a planet? The answers, as it turns out, are never merely structural. Inside Mercury, a giant core tells of violence and survival. Inside Venus, imbalance may have rewritten a world that once seemed like Earth's twin. Inside Mars, a liquid center survives beneath the memory of lost protection. Inside Earth, molten metal still turns in darkness, quietly helping make the surface habitable. And farther out, in the giant planets and icy moons, matter itself becomes unfamiliar, reorganized by pressure into forms that feel almost philosophical in their strangeness. What these worlds reveal is not just variety, but humility. The universe is under no obligation to be simple at the scales that matter most. Its deepest truths are often hidden from sight, inferred through trembling ground, shifting fields, subtle gravities, and light filtered through distance. We do not understand by possessing. We understand by listening, comparing, imagining carefully, and accepting that mystery is not the opposite of knowledge. Sometimes it is the condition that makes knowledge meaningful. There is a human lesson in that. We live in a culture drawn to surfaces, quick impressions, visible outcomes, names for things we have barely begun to understand. But the planets invite another way of seeing. They remind us that what sustains a world may be buried. What transforms it may begin invisibly. and what seems silent may still be alive with motion below. So perhaps the final gift of this journey is not an answer, but a posture, curiosity with patience, wonder with discipline, awe without illusion. To study the hidden interiors of planets is to remember that reality is always deeper than its first appearance. And maybe that is why the search feels timeless. Because whether we are looking at worlds, at history, or at ourselves, the same question remains. What unseen forces are shaping the life of things even now beneath the surface?